Okay, so hi everyone. Um, this is my maths homework, and I thought that instead of just doing it and then just posting it to my tutor, I should actually make a video out of it because it is quite lengthy and we have a lot of variety of questions. So let's start. Okay, so the first question is find three numbers in GP whose sum is 65 and whose product is 3375. Okay, so suppose we take three numbers, say say A upon R, A and AR. All right, then using the fact that their product is 3375, we can say that A upon R into A into AR would be equal to 3375, which means that a cube should be equal to 3375, considering that these r and r get cancelled away, right? So 1 upon r and r, they cancel away in multiplication, so you got a cube equals to 3375. Now let's try to prime factorize 3375. First of all, you can see it's having 25 as a factor, and then into, well, let's see, first of all you got 1, and then you have 13 minus 5, that's 8, and 2 minus 6 is 0, so 875. Then 87, I guess like 25, 50, 75, so that should come. So 13, and then you got 70, 85 minus 75, that is just 105. 105, wait a second, I guess that's not how it should have gone. Okay, so I think I should first erase this. Maybe this is not 25 into 13. Well, first of all, let's factor out of 5 from this so that this becomes simplified. So factoring out of 5, you get this is 5 into 6, 7 and 75, so 25, like 675. Okay, which can further be written as 5 into 5 into well, taking out another 5, you get 1, and then you got 17, so 135, which can be written as 5 cube times taking out another 5, you get 27. So this is just 5 cubed into 3 cubed, which is, yes, 15 cubed. So from that we can say that a should be 15 if a is a real number. So now we know that the middle term is going to be 15. So now we can use the second condition, that the sum is 65. So suppose you have like those three numbers, so you would have like, just move this down maybe. Yeah, so shit, what happened, man, I have to get used to this. Okay, maybe just move it. Okay, I can't move it very well. Okay, whatever, let's just let it be. Okay, so now you know that the middle term is 15, so our three numbers are going to be 15 upon r, 15 and 15r, and we know that the sum is going to be 65. So when you add them up, right, you should get 65. So now you can see that this is becoming a quadratic equation. So now we can cut down a factor of 5 from both terms, from both sides, which will give us 3 upon r plus 3 plus 3r is equal to 13. Okay, and now we can multiply both sides by r, so we get 3r squared plus 3r minus 13r because it comes from that side, and then plus 3 is equal to 0, which can be written as 3r squared minus 10r plus 3 is equal to 0. So 3 times 3 is 9, So when you try to factorize this, you will have 3r square minus 9r minus r plus 3 equals to 0. So you can just take a 3r common from the first two terms. So this would give us 3r times r minus 3, and then you would take a minus 1 common. So once again you get r minus 3 is equal to 0. So from that we can say that 3r minus 1, okay, so 3r minus 1 into r minus 3, this should be equal to 0. This should be equal to 0. So you have r is equal to 3 or 1 by 3. Nice. Which means that these three numbers are actually 15 over r, 15 and 15r, but putting 3 and 1 by 3 we get the same numbers out of that. So you just get 5, 15 and 45 as those three numbers. So that's nice. Now let's go to the next question. Okay, so find three numbers in GP whose sum is 38 and product is 1728. It's a similar kind of question. So let's just write this down, that for the second question we have sum as 28. Well, 28 or what? 38. Okay, 38. So the sum is 38 and the product is just going to see because I forgot the product. Okay, so where is it? Second question. 38 and the product is 1728. Okay, nice. So the product is 1728. Okay. So okay, now let's start doing it. Once again you're going to use the same tactic, that you're going to consider the three numbers as a upon r, and then a, and then ar, and this product is going to be, shit, what happened? Okay, so this product is going to be 1728. Now we want to factorize 1728, so let's pull out a 4 from it. Okay, so it is going to be 4 into 4, 16, 12. This keeps on happening so often. Okay, so 4 out 16, so you got 12, so 3, and then you got 8, so 4, 3, 2. Alright, which can be further written as 8 into 216. And if you remember, 216 is just 6 cubed, so this is going to be 2 cubed times 6 cubed, because 8 is 2 cubed, which is nothing but 12 cubed. So we can say that a should be equal to 12. So a is equal to 12. Alright, now we can use the fact that the sum is 38, which means that 12 upon r, 12 and 12r, wait, what, and 12r, this should be 38. Okay, nice. This we don't want. Okay, so once again we're gonna make a quadratic out of it. So 38 is 2 times 19. Odd. Okay, so you get 6 upon r plus 6 plus 6r would be equal to 19. Okay, cool, this is 19. So from this we can just multiply both sides by r. So we get 6r squared plus 6r minus 19r, because that comes from the other side, and plus 6 is equal to 0. Alright, so now simplifying that, we get 6r squared minus 13r plus 6 is equal to 0. So now we want to figure out two numbers which add up to 36 and which multiply to 36 and which have the sum as 13. I think 4 and 9 will work. Okay, so my guess is 4 and 9. Okay, so we can factor this out. 6r square minus 4r minus 9r plus 6 is equal to 0, which means well, you can just take 2r out of the first two terms, which will give us 3r minus 2 inside, and then you can take minus 3, so you will get 3r minus 2 once again. This is equal to 0. Now you can take 2r minus 3 into 3r minus 2. Wait, what? This is not cool. 3r minus 2 is equal to 0. Nice. So from that we can see that r is either 2/3 or it is 3/2. So once again, just like the previous one, if you put 2/3 or 3/2, you get this, you get same numbers, right? Because that's how geometry progressions work, right? Just in reverse order, you get the numbers in reverse order. So the middle term was 12, then suppose your ratio was 2/3, then you would multiply this by 2 and divide by 3 to get the next term, which is going to be 12 upon which is 4, 4 to 2 is 8, so 12 comma 8, and the first term would be when you multiply by 3 and divide by 2, so it will be 3 into 6, which is 18. So these are the three numbers, 18, 12 and 8, or 8, 12 and 18, considering what ratio you consider. But anyway, these are the three numbers. Now let's move on to the next question. Okay, so find, okay, this is the second question, and now it's the third question. The sum of the first three terms of a GP is 13/12 and their product is -1. Find the GP. Okay, let's do it. So sum is 13/12 and product is -1. Okay, cool. Let's do it. So for the third one, sum is 13/12 and product is -1. We'll just make sure that this is correct. Sum of the first three terms of a GP is 13/12 and product is -1. Okay, correct. Nice. So these three numbers are in GP. The first three terms are obviously in GP, so we can use the same tactic, that considering them a upon r, a and ar, this product is going to be -1, which means that a cube is equals to -1, which obviously means that a should be equal to -1 if a is real. And now we can use the fact that the sum is 13/12 to get -1 upon r. -1 r is equals to 13 upon 12. So multiply by 12r on both sides. This would lead us to -12r squared, and then -12r, and then -13r, obviously, because that also comes to this side, and then yeah, -12. Okay, nice. So now that is equal to 0, which simplifies to -12r squared minus, okay, first of all, just multiply the whole equation by negative. So 12r squared minus 25r actually, yeah, plus 12 equals to 0. Wait, shit, I messed it up. This is supposed to be positive 25 because multiplied by negative. This is positive. Okay, now 12 into 12, what can we factor it into? 12 into 12 can be written as 9 into 16. Oh, that was easy. All right, so it can be written as 9 into 16, so we get 12r squared plus 9r plus 16r plus 25 is equal to 0. Okay, so from this, from the first two terms, we can factor a 3r, so that would give us 4r plus 3, and from the next two terms we can factor out, wait, what, 16, this is weird, 9 plus 16 is opposite 25. Oh shit, this is supposed to be a 12 over there. Sorry, my bad. So it's supposed to be 12 over here. Okay, so from the next two terms we can factor out a 4. So once again we will get 4r plus 3 equal to 0. And now we can factor out this 4r plus 3. So 4r plus 3 into 3r plus 4 is equals to 0. So once again you get the ratio as minus 3 by 4 or its reciprocal, which is minus 4 by 3. In any case, your three numbers are going to be, the middle term is obviously negative 1, considering that the ratio is say minus 3 by 4. So this would be minus 1, 3 by 4 and 4. Shit, what just happened? Okay, sorry. And 4 by 3. Alright, that was nice. So these three are in GP, their product is minus 1, and their sum, yeah, that's 13 by 12, correct, because 16 plus 9 is 25, and then minus 12, that is 13, so 13 by 12, correct. Let's move on. Okay, why does this happen so often? Okay, this was the third question, I guess. Okay, let's go to the fourth one. The product of three numbers in GP is 125, and the sum of their products taken in pairs is 87.5. So I think it's going to be the first term times the second term plus the second term times the third term plus the third term times the first term, which is sum of the products taken in pairs is going to be 87.5. Okay, the product of the three numbers is 125, which means that the middle term is obviously 5. And okay, let's just do this. 87.5. Okay, fine. So the middle term is 5, and I think this was the fourth question. Okay, so the middle term is 5 and their product of pairs is 87.5. So just write that down. A is equals to 5, and now let's take the product of pairs, I mean the sum of the product of pairs. So it's going to be A upon R into A plus A into AR plus AR into A upon R. This is 87.5. Nice. You can just simplify it out, so you can take a squared common, and then here you would be left with 1 upon R plus 1 plus R. Okay, this is equal to 87.5, which can be written as 16 14 is 174 plus 1 is just 175 upon 2. That's nice. And well, guess what, A is just 5, so A square is going to be 25. So we can divide both sides by 25, so you get 1 by R plus 1 plus R is equal to, divide by 25, so that would give us like 4 plus 3 is 7, so 7 by 2. That's nice. So yeah, now it's a quadratic, so we will solve this like a quadratic equation. Just multiply both sides by R, so you get R squared plus R plus 1. Actually wait a second, just multiply by 2R basically. So instead of getting this thing, you can get directly 2R squared plus 2R minus 7R plus 2 is equal to 0. Alright, so we can simplify it further to get 2R, what the heck, okay, 2R squared minus 5R plus 2 is equals to, wait, 2R squared, why is there no square in this? Okay, and which can be written as 2R squared minus 4R minus R plus 2 is equal to 0. That's nice. So now we can just factor it out. So 2R into R minus 2 minus of R minus 2 is equal to 0, which means 2R minus 1 into R minus 2 is equal to 0. So r is either half or it is 2. In any case, the numbers which you get, well, the middle term was 5, so the numbers which you get is 5, 5 by 2 and 10. So that is the GP, I mean the first terms of the GP. So the complete GP would be when you just multiply this by the ratio continuously. In this case, there's a little bit of like situation that you could multiply this by half continuously on this side, or you could multiply by 2 continuously on this side, and we don't know what to do. Let's just read the question once again. Maybe we didn't look at something. Sum of three numbers is product of three terms in GP is 125 small products. Okay, so okay, find them, the product of the three numbers. Oh, so there is no like condition to find a GP. Okay, the sum, next question is the sum of the sum of three numbers in GP is 21, and sum of their squares is 189. Find the numbers. Okay, so sum of three numbers is 21 and sum of their squares is 189. Find the numbers. Okay, let's do it. Just wait, what is 21 and 189. Fine, so 21 and 189, that's nice. Okay, so the sum is 21 and sum of squares is 189. Just writing like this so that I can remember it and I don't have to look up once again. Okay, so this time as we don't like necessarily see any product related condition, maybe we should take the numbers to be AR and AR square, because that will make it little easier to solve. So this sum A plus AR squared, this is going to be 21. Okay, nice. And the sum of their squares is 189, which means that a squared plus a squared r square plus a squared r power 4 is 189. Well, what can we do from this? Not seeing any immediate results, but wait, I think there is something which we can in fact do. Yeah, maybe like we can use cubes and stuff, or maybe not. Well, you know what, I think it would be easier if we just divide this by a to get 1 plus r squared is equals to 21 upon a, and similarly 1 plus r squared plus r power 4 is equals to 189 upon a squared. Okay, now we have to figure out some way of solving it. Is there anything which we can see in common? Oh yeah, we can see a 1 plus r squared. Well, I don't know how that is going to help us. Maybe we can try squaring some things up, or maybe not. Wait, you know what, yeah, let's just square this and take the ratio of it. That would be good, because we can just kind of cancel the a square, so that would kill that term, and we can then just solve for r squared. Okay, that looks cool. So there you go, let's try to do it. Okay, so we're gonna square the first equation and then divide this by the second one. Okay, so that's nice. So we get 1 plus r squared and then you divide this by 1 plus r squared plus r power 4 and just get 21 squared upon 189. 21 squared upon 189. You can easily see that 21 squared is a multiple of 9 and 189 is also a multiple of 9, so you can just cancel out those things. So it's going to be 7 squared upon 20 to 1, yeah, 21, correct. 7 squared upon 21. Hey, that was nice. 21. Okay, whatever. So 7 squared upon 21, which is 7 upon 3. Okay, that's cool. Now where do we go from this? Oh, wait, I think I remember something. Yeah, uh, I remember that 1 plus r squared can be written as r cube minus 1 upon r minus 1. So maybe that will come in handy over here. So the first, like this numerator thing can be written as r cubed minus 1 upon r minus 1, and then this thing is squared. And then the denominator is, well, even that can be written as something cool. It can be written as r to the sixth power minus 1, and then divided by r squared minus 1, because it's almost the same thing, just instead of r you have r squares everywhere. Alright, so maybe you can use that for our advantage. So if we try to, oh wait, yeah, that's just awesome. Okay, so this can be written as, well, the first thing is easy. You just have r cubed minus 1 squared, and uh, when you just kind of simplify it, you get this r square minus 1 on the top. Now I'm going to write this r square minus 1 as r minus 1 into r plus 1. Okay, in the denominator you have this r to the sixth minus 1, which I am purposely going to write as r cubed minus 1 into r cubed plus 1. Well, nah, this is crazily good. Okay, this is crazy good. Yeah, and also this one, r minus 1 squared. I don't want to miss that. Okay, so this complete thing is in division, and this is equal to 7 upon 3, this weird thing. Okay, now here's the thing, a lot of things will cancel out completely. So for example, this will cancel out with this square. You have this r minus 1 cancelling out, so you just have r cubed minus 1 upon r cubed plus 1 and r plus 1 upon r minus 1. That's nice. That's just really nice. Okay, and now you know what, you can use the fact that r cubed minus 1 upon r minus 1, well, that is just r squared minus r plus 1. Wait, but no, r squared plus r minus 1. So in short, we're just writing r cubed minus 1 in its factorized form. Okay, so that can be very useful. So we can write this as r squared minus r plus 1, and similarly r cube plus 1 can be written as r plus 1 into r square minus r, wait, sorry, this was supposed to be r square plus r. And similarly r cube plus 1 can be written as r plus 1 into r square minus r plus 1. So that r plus 1 and that r plus 1, they will just cancel out. So you would have this divided with r squared minus r plus 1. Okay, and this would be equal to 7 by 3. That's nice. I mean, this is really nice. I did not expect it to come out like that. Okay, now this is looking easy. Just cross multiply out the equation. So you get 3r squared plus 3r plus 3 is equal to 7r squared minus 7r plus 7. Nice. Wait, what? That's not a 7. Okay, this is a 7. Okay, let's simplify. So we will get 4r squared. Shit, why is this happening with me? Okay, wait, you know what, let it be. 4r squared, and then you have minus 7r minus 3r is just minus 10r, and then plus 4 is equal to 0. Alright, so 4 into 4 is 16, which can be written as 8 into 2, and 8 plus 2 is just 10, so that's nice. 4r squared minus 8r minus 2r plus 4 is equal to 0. Okay, from this we can factor out a 4r from the first two terms, so r minus 2, and then we can factor out a minus 2 from the next two terms, so like r minus 2 is equal to 0. That's nice, which makes it that now just divide this whole equation by 2, so you would get 2r minus 1 as the first factor, and then you have this r minus 2 is equal to 0. So r is either 2 or it's half. Both have the same effect. Well, what was our middle term? We don't know, so we'll just have to figure it out now. Actually, we don't even have a middle term. A was our first term of the sequence. Alright, so what equation did we make? Yeah, this one. 1 plus r squared is equals to 21 by a. We can just plug in the value of r as 2 in this to get the value of a. That should be a piece of cake. Okay, let's do it. And similarly, we can just plug in the value of r as half to get another value of a. So hopefully that will give us 2 gps. Okay, 2 gps. Let's just use that thing. Okay, first of all, just select this whole equation and I'm going to move it. Oh wait, okay, let it be. Just don't move it. Yeah, we can deal with it. Okay, so 1 plus r squared plus r is equal to 21 upon a. So there you go. Wait, what happened? Just what happened? Okay, why is this not happening? Wait, why? Wait a second, huh? I mean, I'm facing some kind of problem. Oh, sorry, I was not equipped with a pen. Okay, this is going to be 21 upon a. Okay, that's nice. So we just found the value of r to be either half or 2, so we are just going to put those in this equation. If you put the value of r as 2, you would get 1 plus 2 plus 4, which is 7. So you would get a is equals to 3. So a equals to 3. That's nice. For r is equal to 2. And let's see what happens when r is equals to half. When r is equal to half, you get almost the same thing. You get 7 upon 4 is equals to 21 upon a. So 7 upon 4 equals to 21 upon a. So you would get a equals to 12. Nice. A is equals to 12 for r equals to half. Okay, so now let's create those three numbers, a, ar and ar squared. If a is 3 and r is 2, then you just get 3 in 12. No, wait, 3 and 6 and 12. And if that's nice. I mean, you still get the same numbers. If a is 12 and r is half, you just get 12, 6 and 3. So okay, we still get the same numbers. So no two different GPs, just the order is completely opposite. That's nice. So let's move on to the next question. Okay, let's just put this somewhere nice. Which question was this one? Okay, this is the fifth question. Let's move on to the sixth question. The sum of three numbers in GP is 14 if the first two terms are each increased by 1 and the third term. You know what? I think I just want to erase some stuff right now. So I will erase all this mess. Yeah. Just delete this. And similarly this. Alright, so open this thing, just move it down. That's nice, ready to go. So the fourth is done, sixth is also done, seventh. Okay, seventh, no, we are on the sixth question though. So the sum of three numbers in GP is 14 if the first two terms are each increased by 1 and the third term is decreased by 1. The resulting numbers are in AP. So suppose these three numbers are a, ar and ar squared. So when you just kind of add them up, this becomes, the sum is what we said, okay, 14. So and the next equation is that when you just add 1 to the first one, 1 to the next AR one, and you subtract 1 from AR squared. Now these three numbers will be in AP, so you would get that this new middle term will be the arithmetic mean of the first and the last term, I mean the new first and the last terms. So we can write that 2 times of AR plus 1 is equal to A plus 1 plus AR squared minus 1, which is just A plus AR squared. And here's the deal: A plus AR squared we already know is just 14 minus A. Well, how? From this equation. From this equation we know that A plus AR squared is nothing but 14 minus A. No, sorry, 14 minus AR, sorry. That's nice. Okay, so this thing is going to be 14 minus AR. So we can take AR as X and just solve for AR. So you will get like 2x plus 2 is equal to 14 minus X, which means that 3x is equal to 12. So X is equal to 4. So we get AR is equal to 4. Well, how does that help us? Okay, you got the value of AR, so you also know what is A plus AR squared and all that stuff. Hey, AR is 4, so we can just substitute the value of R as 4 upon A. That will almost, yeah, it will just reduce our burden. So substitute the value of R as 4 upon A into this equation, or even like this equation will work. Okay, this equation. So you will get A plus AR is just 4 plus AR is 4 times R. So 4R is nothing but 4 times of 4 upon A, which is just 16 upon A, and this is 14. That's nice. So that can be okay, that can be written as A squared. Well, you know what, just 4 and this 14 becomes 10, and then it moves to the left hand side to become minus 10. So you would get A squared minus 10A plus 16, and sorry, this is 16 not 6, is equals to 0. That's nice. So once again, same thing, 16 is equals to 8 into 2, and then 8 plus 2 is just 10. So you would get A minus 2 into A minus 8 is equal to 0. So either A equals to 2 or A equals to 8. That's nice. So when A is equals to 2, our R is just 4 upon A, which is okay. So A equals to 2 gives R as 4 upon 2, which is nothing but 2 itself. And when A is equal to 8, R is equals to half. What? No, that's not cool. R is equals to half. Okay, cool. So let's just generate that GP right now. So if A is 2 and R is 2, you just get 2, 4 and 8. If A is 8 and R is half, you just get 8, 4 and 2. Same stuff, right? Same 3 numbers. Okay, let's move on. This is the 6th one. Let's move to the 7th one. The product of 3 numbers in GP is 216, which means the middle term is going to be 6, because 216 is just 6 cubed. If 2, 8, 6 are added to them, the results are in AP. Find the numbers. Okay, the results are in AP. So I think it's going to be 6 is the middle term, so it's going to be 6 upon R, 6 and 6R. Okay, those will be the 3 numbers, and 2, 8, 6 are added to these 3 numbers, and the results are in AP. Oh, that's nice. So in other words, you have A upon R plus 2, comma A plus 8 and AR plus 6. These three numbers are in AP. So just like the previous one, take 2 times the middle term, that's going to be the sum of the first and last terms. So you get 2A plus 16 is equal to A upon R plus AR plus 8. That's nice. So from this we get, yeah, it's gonna be just another quadratic, I guess. But wait, do we know what A is? Obviously we know what A is. A is just 6. Easy as that. So when you put value of A as 6, you just get 12 plus 16 minus 8 is just 8. So 12 plus 8 is 20. It's equal to 6 upon R plus 6R. Just cut out a 2 from it. Actually multiply by 2R, that will be better. Actually multiply by R by 2, that's better. So just get 10R is equal to 3 plus 3R squared. Nice. So once again it's going to be the same equation, 3R squared minus 10R plus 3 equals to 0. So 3R squared minus 9R minus R plus 3 equals to 0. So you get 3R in common from the first two terms, and then there's just R minus 3. And going through all that long process, we can already see that R equals to 3 is a solution of this equation, because 10 times 3 is just 30, which is equals to 3 plus 3 into 3 square is just 27. So 27 plus 3 is 30. So R equals to 3 is a solution, and now we know that how it comes in pairs. So R equals to 1/3 is also a solution. Nice. Wait, okay, so R equals to 3 or 1/3, and you obviously have the middle term being 6. So it doesn't matter, right? So the GP is just going to be say 6 and 18 and 2. That's nice. This is going to be the GP. Okay, let's move on to the next one. This is another one. Okay, find 3 numbers in GP whose product is 729. 729 is 9 cubed, so the middle term is going to be 9, and the sum of the products in pairs is 8, 1 and 9. Okay, 819. Why does it look so familiar? Because we have already done one such question. Okay, let's just erase this all first, because I'm tired of moving down. Delete. Yep, delete this too. Oh, come on, just delete it. This is tiresome. Delete, 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 delete. Okay, let's solve this fast. So this is the 8th question. So the product is 729, which means that the middle term is going to be 9, and the sum of the products in pairs is 8, 1, 9. So see, these 3 numbers are going to be 9 upon R, 9 and 9R. So when their product is taken in pairs, right, so you get 9 upon R into 9 is just 81 upon R, plus 9 into 9R is 81R, plus 9R into 9 upon R is just 81, and this thing is equal to 819. Another thing, that 819 is just a multiple of 9, so you can cancel out 9 as a factor from this. So you get 9 upon R plus 9R plus 9 is equal to 91. That's nice. So now let's multiply this by R on both sides. So you get 9R squared plus 9R plus 9 is equals to 91R. So now let's move this 91R to the left hand side. You get 9R squared plus 91 minus 9 is just 82. Wait, what? No, not plus. It's going to be minus. R squared minus 82R plus 9 is equals to 0. That's easy. 82 is just 81 plus 1. so that's going to be another easy one. Okay, you get 9r squared minus 81r minus r plus 9 is equal to 0. So from that we can say 9r into r minus 9 minus of r minus 9 is equals to 0. So wait, what is this thing? This is supposed to be 0. So r is equals to 1 by 9 or 9. It makes no difference because you still get the same three numbers. I just move it up. And what was the middle term? 9. Oh, that's nice. So yeah, the GP is going to be 1, 9 and 81. It's like that. This was easy. Okay, first of all, I just want to clear some stuff once again. And just clear this, delete, and also like delete this thing, delete, and then delete this also, so delete. Okay, let's move on to the next question. I think this is the last question. Okay, the sum of the first three terms of a GP is 39 by 10 and their product is 1. Oh, that's nice. The middle term is going to be 1 and sum is 39 by 10. Find the common ratio and the terms. Another similar kind of question. So the middle term is just 1, so it's just going to be 1 upon r, 1 upon r plus 1 plus r is equal to 39 by 10. Okay, I think it's going to be another crazy quadratic thing. So 10r squared plus 10r plus 10 is equals to 39r. Okay, so this is going to be minus 29. What? Okay, so you get 10r squared minus 29r plus 10 is equal to 0. Okay, so 10 times 10 is just 100, which is also 25 times 4. So this can be broken as 25 and 4. So 10r squared minus 25r minus 4r plus 10 is equal to 0. Okay, nice. So you can just factor out 5r from the first two. So 5r into 2r minus 5 and then minus 2 into 2r minus 5 is equal to 0. So r equals to 5 by 2 or r is equals to 2 by 5. We can already see this. So now the middle term was 1. So the three numbers are going to be 2 by 5, 1 and 5 by 2. That's it. These are going to be the three numbers. Okay, so now it's completely done. Did all the 9 questions. Now I'm gonna rest. Okay, so thank you for watching this and seeing how tired I get. I don't think I will ever do these many of questions at once. I mean, I can actually do these many of questions at once, but because this time I had just formally write down everything, I got so tired. Anyway, have a good day or good night. I mean, depending on what hour it is right now. Whatever. So I'm just gonna go to bed. Thanks.